The topic of this video is composition of functions. I'm going to use this diagram of a function machine. Let's call this function f. So we've talked about functions before. The idea behind a function is that you put an input into the function. So let's suppose I put the number 2 into the function. Something happens to the number 2 and out the other side comes the output. Let's say the output is 5. The only real restriction on functions is that there's this association between inputs and outputs, but the rule that makes it a function is that every input has exactly one output. So for example, we have the input 2 here, and there's the output 5 that's associated with the 2, but you cannot put a 2 in and also get a 7 as well or something like that. And oftentimes, you don't have to have this for a function, but we often have these function rules where you have an actual equation. So the equation, for example, for this one could be 2x plus 1. So when I put that 2 in, we're doing 2 times 2 and then plus 1. The way we do that when we're writing it out by hand is we say this is evaluating the function. So we say f of 2, and we rewrite that little expression right there, but we just put a parentheses where we see the x, and then we plug in the number that is our input, which is the number 2, and then we simplify this. So 2 times 2 is 4, plus 1 is 5. Okay. Now, the question is, what would happen if we plugged in something other than a number? Could we actually do that? And I'm going to try to argue to you that we can do that. So let's say we put in the expression 3x. So if I just blindly kind of work it the same way as I did when we put in a number 2, I might say, well, we're trying to figure out what f of 3x is, right? So f of 3x is, and then we write the expression 2 parentheses plus 1. And then we say, well, what are we putting in as the input? Well, we're putting in a 3x. So we put a 3x in where we see the parentheses. And then we just try to simplify this. Now, it's not going to be a number, but we can still simplify this. This becomes 6x plus 1. So there you go. This is called composition of functions, what we're doing. Why would it be called composition of functions? Well, we're composing or bringing together functions. You can look at this 3x here and you can say, well, that's 3x, that's just an expression. Or you could say, wait a minute, this is a function. We could call it g of x. g of x equals 3x. So what we're kind of doing down here is we're trying to do f of g of x. g of x is 3x, and that's what we were doing. We were replacing g of x with 3x. Well, we have a special notation for that. That's what I actually have written up here. And it's f circle g, and then we have x over here. These two things mean exactly the same thing. Now, I do want to show you something interesting here. So what you might ask yourself is you might say, well, can I do something like f circle g of 2? What would that mean? Okay, well, looking at this expression right here, this little formula right here, this equation, so f circle g of x is f of g of x. So f circle g of 2 would be f of, and then g of 2. Okay, well, there's g of 2, right? Well, what is g of 2? Well, we go back up here. We say, oh, wait a minute, g of x, that's just 3x. So g of 2 must be 3 times 2. That's just going to be 6. So this is just the same thing as f of 6. And f of 6, because f is 2x plus 1, is going to be 2 times 6 plus 1, which is 13. Okay? Now another way we could have done this is we could have looked back here, because f circle g of x equals f of g of x equals f of 3 of x equals all of this. This here is f circle g of x. That's the formula for that. So another way we could have done this is we could have said f circle g of 2 equals, and then just use this expression. This is the expression that is f circle g of x. So that's going to be 6 times our input, which is 2, plus 1. That's 12 plus 1, which is equal to 13, which is the same as what we already got. So both ways get us the exact same thing. So the idea here, again, is that f circle g, which we call composition, we are putting a function inside of another function to get some sort of output. Okay, so what we just did with that 2 was it's kind of tricky with this, the amount of space I've got here, but if you imagine g as a little function like this, I'm going to try to draw a little function machine right here. Okay, we are putting the number 2 into g, and then out of g comes the number 6, so we get the number 6, and the number 6 goes into f, and then out of f comes the number 13. All right. Now I want to show you some examples, and I'm actually going to pick these from the homework. And this is homework number 10. I want to show you how to do this problem here. This is excellent review for quiz number 5 and for the Unit 3 test. I have looked through the quiz and looked through the Unit 3 tests to make sure that the kind of questions that I'm doing right now are the kind of questions that you're going to see on the test. So this one here says G circle f of 2. When I look at that, I'm going to see if I can write on here or not. No, it's not going to let me write. That's okay. So I need to find G circle f of 2. I'm going to put this window to the side here, and I think I'm going to open up a new window here. So G circle f of 2 is just like what we did. This is the same thing as G of f of 2. Now when you're evaluating a function using a table, what is happening here is instead of them giving you an equation where you can plug numbers into the equation, they give you some x values and they give you some y values. Remember, don't ever forget that y is f of x. F of x is y. These are the same thing. So when it says f of x, that's the same thing as y, or the output. So these are all the inputs to this function f, and these are all the outputs of the function. These are the inputs to this function g, and these are all the outputs. So if I want to find f of 2, for example, I go over to the table that's for f, and I say, well, my input needs to be a 2. Okay, so there's x equals 2. What's the output with that 2? Oh, that's a 7. So f of 2 is 7. So this just becomes g of 7 like that. I've calculated, or I've not really calculated, but I've looked up in the table to figure out that f of 2 is 7. Then I just go ahead and look up in the table and see what g of 7 is. So I go to the table for g, I go up here to the x's, I go over to 7, and I see that there's an 8 associated with that. So g of 7 equals 8. And I'm going to try typing that in and see if that's correct. And it appears to be. And then it's going to have me do it the other direction. This is the same process going the other direction, so I'm going to let you do that one. So you will see a problem like this. Keep that in mind. Question number 7. Okay, use the given function f and g to evaluate each expression. We've done a problem like this already. It is just different formulas. So I think I will do this one though, because I do want you guys to understand this really well. So this says f circle g of 2. So this is f of g of 2. Okay, now you might just say, well, what is g of 2? G of 2, g is just x squared. So that's just going to be 2 squared. So that's 4. So that means that g of 2 is a 4, so this becomes equal to f of 4. And f of 4 equals, I'm not doing this very well, I'm kind of running out of space here, I'm doing the equals right here. That equals the square root of x, well, that's going to be the 4 plus 77. Alright, so that's the square root of 81, which equals 9. So I think that answer there is going to be 9. Okay. There's a couple of other problems that I want to take a look at. Yes, this is very, very important. These are domain questions. All right, question 8, question 9. Yeah, 8 and 9 are both very important on the test. Let's try both of these and see what we can come to. I'm going to teach you how to do it first. So the question states, for the given functions, find f circle g of x and g circle f of x and the domain for each. Okay, the domain is the key consideration. Let's just go ahead and find f circle g of x. So f circle g of x is f of g of x. Okay, now this is a bit tricky here. Okay, so f of x is 2x plus 1. So this is 2 times the input plus 1. But the input is, we can write this right here, g is the square root of x. So we're trying to find f of the square root of x. So I'm going to take that square root of x and I'm going to put it in the spot for x here. So that's just the square root of x right there. So this is just 2 times the square root of x plus 1. Let's go ahead and type that in. 2 square root x plus 1. Okay, now they're going to have us do it the other way around. One of the things that you'll learn after you do these is that most of the time f circle g is not the same thing as g circle f. Okay, as always, I'm going to write this as g of f of x. So f of x is 2x plus 1, so this is g of 2x plus 1. Okay, now that means g is just the square root of the input, so that's the square root of 2x plus 1. I know that you could do that. I am just typing this in so that we can do the second part of this question here. All right, so now they're asking this great question. They're saying, what is the domain of these things? So we have the domain of f of g. That's the first question. That's going to be this expression up here. You basically just need to check two things, okay? You need to look at the final answer and ask yourself, what is the domain of the final answer? All right, I'm looking at this, and there's only two things that you need to check for when you're checking for domain. You need to look for square roots, and you need to look for fractions where you have whatever is in the numerator, and then you have something that has an x in the denominator. So it might be like 2x or something like that. This is what you want to make sure. You want to make sure that when you're taking square roots, you only take square roots of non-negative numbers. That means that your numbers that go inside the square root could be a 0, or they could be any positive real number. Looking at this, I see the square root of x, so I know that the numbers that go in here have to all be 0 and positive numbers. Okay. There are no fractions here, so I do not have to worry about that. So just a quick glance at that will tell me that my domain is going to be from 0 to positive infinity, and they have a bracket around the 0. The reason for the bracket is because it is okay to take the square root of 0. The square root of 0 is 0. The square root of a negative number would be imaginary. That's why we're not doing that. And then it goes up to positive infinity. The other thing we have to check for is the original input function. So the input function was g, and sometimes things can happen where you also have to check the domain of that. Now for us, g is pretty easy. G is the square root of x. It has the exact same domain as this final one there. So our domain should just simply be 0 to positive infinity. However, we'll see with the second problem. So we got the second problem down here. It's not quite as simple. Okay. So the input is 2x plus 1. Now there's no square roots in here, and there's no fractions, and so we do not have to worry about the domain. The domain for 2x plus 1 is all real numbers. But the domain for this final one, we have to look at this very carefully. The value of this expression cannot be negative. So we want the value of that expression to be greater than or equal to 0. And so I just write it down. And then I can go ahead and solve this inequality. Now you solve linear inequalities the same way you do equations. I'm just subtracting 1 on both sides here. The only extra rule is that if you ever divide or multiply by a negative number, you change the direction of the inequality. Well, I'm going to divide by a positive 2, so that's not going to change the direction of the inequality, and I get x is greater than or equal to negative 1/2. So coming over here, that means that's going to be the number negative 1/2, and then all the numbers that are greater than that. So that's going to be from negative 1/2, comma, to infinity. Okay. All right. Let's take a look at this one. That one is not particularly difficult, so I'm not going to do that. All right, I think that does it for this video, and I'll see you in the next video.